Okay class, so today we will start with our next new chapter, that is chapter number 5, acid, bases and salt. So we use in our daily life a large number of substances such as lemon, tamarind, common salt, sugar and vinegar. Do they have the same taste? No, they have different taste. And why is so? It is because of their chemical nature class. Okay? Because the constituent of these different substance is different. They are made up of different chemicals. That's why they differ in taste. So class, now we will discuss topic wise about acid and bases. So as you can see here, curd, lemon juice, orange juice and vinegar taste sour. These substances taste sour because they contain acids. The chemical nature of such substances is acidic. The word acid comes from a Latin word acere, which means sour. The acids in these substances are natural acids. What about baking soda? Does it also taste sour? If not, what is its taste? Since it does not taste sour, it means that it has no acids in it. It is bitter in taste. If you rub its solution between fingers, it feels soapy. Substances like these, which are bitter in taste and feel soapy on touching, are known as bases. The nature of such substances is said to be basic. A special type of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators change their color when added to a solution containing an acidic or a basic substance. Turmeric, litmus, China rose petals, etc. are some of the naturally occurring indicators. Okay class, now we will learn about a natural indicator. Okay, so the first heading under this is litmus, a natural dye. The most commonly used natural indicator is litmus. It is extracted from lichens, and as we all know that lichen is a symbiotic structure of algae and fungi. It has a mauve, that is purple color, in distilled water. When added to an acidic solution, it turns red, and when added to a basic solution, it turns blue. It is available in the form of a solution or in the form of strips of paper known as litmus paper. Generally, it is available as red and blue litmus paper. Now class, I will tell you about a particular group of solutions who will not turn either into red or into blue. They will just remain as same when the indicator is added to those solutions. So the solutions which do not change the color of either red or blue litmus are known as neutral solutions. These substances are neither acidic nor basic. Some other natural indicators of acid or basic nature other than our litmus paper, there are two main natural indicators. One is turmeric and the other one is China rose petals. Class, now we will move to our next topic, that is neutralization. So when an acidic solution is mixed with a basic solution, both the solutions neutralize the effect of each other. When an acidic solution and a base solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the base are destroyed. The resulting solution is neither acidic nor basic. In neutralization reaction, heat is always produced or evolved. The evolved heat raises the temperature of the reaction mixture. That means class, whenever we will mix an acidic solution with a basic solution, the resultant solution will always release heat, and whenever you will touch the test tube or whatever apparatus you have taken to mix the solution, you will always feel it as heat. Okay. So in neutralization reaction, a new substance is formed. This is called salt. Salt may be acidic, basic or neutral in nature. Thus neutralization can be defined as follows. The reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. So as you can see here class, that acid plus base giving rise to salt plus water with heat. The following reaction is an example of this neutralization process. If you see here, there is a reaction given here. Here hydrochloric acid HCl is added with sodium hydroxide NaOH. So here hydrochloric acid, as you know, it is the acid here, and sodium hydroxide is the base here, and when we are adding base with the acid, we should get one salt and then with water. So here the salt that is formed as sodium chloride NaCl plus with water H2O. Now class, we will discuss about our next topic, that is neutralization in everyday life. The first topic is indigestion. Our stomach contains hydrochloric acid. It helps us to digest food, as you have learnt in chapter 2. But too much of acid in the stomach causes indigestion. Sometimes indigestion is painful. To relieve indigestion, we take an antacid such as milk of magnesia, which contains magnesium hydroxide. It neutralizes the effect of excessive acid. Now coming to the next topic, that is ant sting. The sting of an ant contains formic acid. When an ant bites, it injects the acidic liquid into our skin. The effect of the sting can be neutralized by rubbing moist baking soda, that is sodium hydrogen carbonate, or calamine solution which contains zinc carbonate. Next is soil treatment. Excessive use of chemical fertilizers make the soil acidic. Plants do not grow well when the soil is either too acidic or too basic. When the soil is too acidic, it is treated with bases like quicklime, that is calcium oxide, or slaked lime, that is calcium hydroxide. If the soil is basic, organic matter is added to it. Organic matter releases acid which neutralizes the basic nature of the soil. Next topic is factory waste. The waste of many factories contain acids. If they are allowed to flow into the water bodies, the acid will kill fishes and other organisms. The factory waste are therefore neutralized by adding basic substances. I hope that all of you have understood the topics well, class. That's all for today's class. Thank you, class.